Brew Strong is brought to you by Blickman Engineering, home of the Riptide. Visit them online at blickmanengineering.com.
Brew Strong is brought to you by Blickman Engineering, home of the top-tier brewing stand. Visit them online at blickmanengineering.com.
It's time for the beer radio you've been looking for. This is the show that dispels myths, tackles the toughest topics, and makes no apologies for geeking out on beer. Hosted by two guys that drink before they think, Jamil Zainasheff and John Palmer. This is Brew Strong.
Howdy, hey, my brewing brothers and sisters.
Greetings, cretins.
That was pretty cool, John.
Yeah, you almost seemed uncertain there, my friend.
Well, the echo threw me off.
Yeah, are you in your isolation chamber? Is that where the echo is coming from?
Yeah, it must be. I'm here in my ice cave and Fortress of Solitude, and.
Yeah, see, I don't think you're going to get any sympathy from the people, in the Midwest that were suffering at the minus 50 degrees.
Yeah,
recently.
That's probably true.
You're still in California. What is it down to? Like 40 or something where you're at? Is that the problem?
It's 40, yeah.
We can barely wear our flip-flops.
Right.
Oh, yeah.
In the words of Dr. Evil, boo frickety hoo.
Yeah.
It's actually a balmy 32 degrees here today.
Yeah. Well, we have on the other line John Blickman, our fine sponsor and friend, inventor of many interesting things, and some of them involved in brewing, like the Cornicle and the Brew Easy, and so many other cool inventions. Beer gun. Everybody heard of the beer gun? Anyways, John's going to join us today for a show about measurements. We actually thought, Bevo, you make me laugh. We actually thought it would be an interesting subject to cover in some depth, especially the measurements that are critical to breweries.
Right.
Yeah, and it's, you'd mentioned that as a topic, and I instantly thought that's a great topic because there's so many measurements we do, and I've really not, really heard a podcast that covers just that. So I think this is going to be a great show.
Right. And, one of the things that got me thinking about it was a lot of the failures of homebrewers early on is in failure to measure. People are failing to measure, their temperatures, especially in fermentation. Precise temperature control is actually quite important in fermentation. Pressures when they're carbonating, volumes. I can't tell you the number of people that say, "Oh, yeah, well, I didn't get the efficiency I want," or "Yeah, I'm getting over 100% efficiency. Boy, I'm doing really well." It's like, well, you're probably messing up your measurements. Our weights, they're struggling to repeat their recipes because they're not getting weights right, or they're struggling to measure really small amounts, like maybe a zinc addition on a 5-gallon batch is really minuscule, and there's some tips and tricks to kind of get around that. I don't know, maybe lengths. I don't know. Do people struggle measuring lengths? I know Scott and I both can measure easily a foot. Yeah. Whether
that's where calibration comes in.
Right.
It's a specially designed ruler.
Comparison, yes.
Rubber ruler.
And we should probably mention in there gravities, specific gravities, densities
the effective
of liquids.
temperature.
Mm-hmm. Well, and that's a big part of measuring temperature accurately. You can't really measure your specific gravities without being able to measure your temperature. A lot of times people are just kind of going, well, it feels like 60, or they're not adjusting. So a lot of those things, I think, are it bears some in-depth discussion, let's say.
Yeah, we get people saying, "Hey, my graduations are off on this kettle or whatever," and one of the first things we ask them, "Well, how are you measuring it?" Because it's as when you're in engineering school, John remembers this, and you probably do as well, Jamil. Is the first thing you do is question your measurement. You need to be damn sure your measurement is correct before you go taking action otherwise.
Right. Yep. That's we had a high CO2 reading, and we're all running around trying to figure out where a CO2 leak is coming from, and then I'm like, well, are we sure that the meter is reading correctly? Because nothing seems to have changed, and we don't find a leak, so maybe the meter's off. So, that's definite good point. Well, I think we ought to start like we usually do with some definitions of that relate to our subject. So we're going to do a series of shows, and we're going to cover temperature and pressure and volume and weight and probably densities. Maybe I'll throw in a few tips on length. I'm just saying. I've got my own little tips and tricks.
If you'll pardon the term tip.
Well, you measure.
I knew that was going there.
You want to measure from the tip to the base, or from point A to point B.
And it is a matter of perspective.
You want to get your hose length right. You don't want to cut your hose too short, and then you're not reaching like our friend Porno Steve. It's too short a hose.
Yeah,
just having to
that'll happen.
Drop it from the ceiling to some bucket below. And he didn't measure his specific gravity, and this would be a good show for him.
Indeed, I guess that's you inspired this show,
right? Exactly. And it's common. So if you're one of the people that hasn't really been measuring things correctly, we're here to help. We've got lots of information, and I think this applies to pro brewers too, because a lot of people, especially transitioning from home brew to pro brew, they don't have a lot of insight into when you have errors in measurement. In homebrew, it's not a big deal. When you have errors in measurement in the commercial side of things, you can end up with an ABV that's off and out of spec, and then the TTB, they go around and check, and they will tell you if you're and send you a nasty letter saying, hey, this beer is not what it says on the label. So you have to be careful of that. It actually does matter. And, small errors in measurement can be multiplied greatly the bigger you get. John, why don't you start us off, Palmer, why don't you start us off with some basic definitions of measurement?
Sure. Well, yeah, we talk about, accuracy, precision, and resolution. And resolution is your ability to, the degree to which you can differentiate results. Mm-hmm. And very often it's, measured in terms of your decimal points. Is it, 1 decimal point place, 2 decimal places, tenths, hundredths, thousandths, that sort of thing. And resolution is great, but if you don't have accuracy and precision, you really have nowhere to go with it. Now, accuracy and precision are a little different. Accuracy is like resolution, and but accuracy is basically how calibrated your results are. You say something is 1 liter or 10 degrees or 15.0 feet, your accuracy is how calibrated that measurement actually is. Precision is how repeatable your measurements are. This is really more, more prevalent in electronic instruments, say, than physical measurements like a ruler. But you want, if you measure the same pH of a solution of your wort twice, or the temperature twice, do you get the same result or you get a drifting result? And that is precision.
So
it's kind of like the grouping of your measurements.
Right. So if you had a bent ruler and it would always measure 5 inches, but really it was 6. Your precision is still high, but your accuracy is off.
That's correct. Yes.
Amongst other problems.
Right. And the resolution on that ruler might be the gradations, the number of lines on the ruler is kind of the resolution of the ruler, the resolution of the tool you're using to measure.
Yeah. You can insist that it's actually 5.1 or 5.15,
right.
But most people just round to 5.
There you go, or up to 6. I'm just saying.
Or up to 6. Yes.
I mean, bent ruler,
depending on your applications.
Yes. Right. Okay. Well, and John Blickman, speaking of the bent ruler, the same thing happens. I've seen this on gauges. I buy a lot of gauges for tanks and things like that at the brewery. And we check them all on we made our own little bench gauge. And they'll be off, 4 PSI, 7 PSI, plus or minus, so it's a massive range. It's like a 1 atmosphere range of error on these things.
Yikes.
And that's fine. I mean, they can be adjusted, but, most people are not going through that. They're buying a gauge, brand new, and they're like, well,
assuming
it's new.
It's right.
Yeah. And it may not be. Same thing for temperature, pressure, what have you. They could all be off. So, I mean, there's calibration. So, tell us, what exactly we're talking about with calibration. And kind of.
I'll use an analogy it's typically used in the measurement, and it shows a series of targets, and it talks about the difference between accuracy and precision, like John was talking about. But in there, I'll talk about it a little bit, and I'll show you the relationship between those and calibrating. So something that's accurate and precise would be, all the rifle holes through the bullseye. That would be accurate and precise. Now you can have a very precise rifle that's not accurate, meaning all the bullets are pretty much, bullet holes are right next to each other, but it's way off the bullseye. That's precise but not accurate. You can also have something that is accurate but not precise. So it's all centered around that bullseye, but they're just kind of not real tightly grouped together. That would be accurate because it's representing overall the center of the target, but it's not very precise. And then there's stuff that looks like you were drunk when you were shooting, and they're all over the target. So that's not accurate or precise. Now,
so that explains my shooting. Yeah.
Yeah. So when the key thing you really need to be able to, to be able to calibrate something is precision. So they have to be grouped together. The numbers have to be grouped together, as John was talking. When you put that pH meter in, it needs to read very close to the same thing every time. So once you have that, you can actually then, it's like adjusting the scope. You adjust for windage and you adjust for elevation, and you can bring that grouping of bullet holes right into the center of the target. So that's really what we're doing with calibration is first we have to work on precision, and then we can, like in the a lot of pressure gauges will have an adjustment screw. Same thing with thermometers, like a dial thermometer will have an adjustment screw. And so if you've given that a known, so you're really, that's the other thing, is you're comparing it to a known. When I get a new instrument, I always assume that it's not correct until proven otherwise. So I go and find a known. And in the case of temperature and other gauges, there's you can get NIST certified instruments. So it's National Institute of Standards and Testing, I believe is what that is, isn't it, John?
Yes.
And so you can buy these instruments, and these labs will certify it very closely. And then what you can do in the case of pressure or temperature is you put those two devices close to each other in that vessel or in the liquid, and you just compare them. And so I've got one that's a known, and then I can adjust my other one over to meet that. That's great if you've got enough money to buy one of these NIST certified temperature or pressure gauges. But a good way to do that for a thermometer, for example, is use a couple of known type temperatures. And one of the easiest ways to calibrate a thermometer is the ice bath method. And I recommend using distilled water and making some ice cubes, and getting a little insulated vessel and put some ice, about half ice cubes, half water in, and wait a few minutes for that to come to equilibrium. And then you can place your thermometer in there and get a reference of 32 degrees Fahrenheit or 0°C. And then you can get you can adjust your thermometer while leaving in that liquid to meet that. You can do the same thing up on boiling. It's just a little more risky with the steam and boiling water. But it's also good to get a couple references, because it could very well be accurate at 0 degrees Celsius, but at 100 degrees Celsius, it may be off. So I take things a little step further and say, where is the temperature the most important for me? And for mashing, for example, I always pick about 154 degrees because that's the critical-ish temperature range where I want to be most accurate. So we've got a calibrated temperature bath, oil bath that we use, and I will calibrate sensors with that. In a home environment, the other thing you can do if you want to do something like that to have a check, I find that the Thermopens, the Thermopen brand, they're not cheap, but they're I found them to be very close and consistent over time to use a Thermopen as a reference temperature.
All right. Well, let's do this. We need to take a short break, and when we do, we'll come back. We'll talk about various devices and how you might calibrate them, what they're useful for, and the best ways to utilize them for greatest accuracy. All right. We'll be back right after this.
Are you looking for a simple brewing system that's great for all grain brewing, but everything on the market seems to be full of compromises? Blickman Engineering has the answer. The Blickman Brew Easy All Grain Brewing System. The Brew Easy is a complete system with easy upgrades and a beautiful compact design, perfect for any size brewing location. At its core, the Brew Easy is built on two gorgeous Blickman Boilermaker brew kettles, a high-temperature March pump, and either a top-tier gas burner or the new Boil Coil electric heater. The Brew Easy adapter lid allows the pots to stack on top of each other, forming an efficient, strong, and compact brewing setup that comes in 5, 10, and 20-gallon batch sizes. Upgrade your Brew Easy system with full automated control by adding a Blickman Tower of Power temp controller, and make moving around easy with the Blickman Kettle Cart. The Brew Easy is modular. If you already own a Boilermaker kettle, you can build your Brew Easy by purchasing just the modules you need. The new Brew Easy All-Grain Brewing System. See it today at BlickmanEngineering.com and brew with Blickman quality on your new Brew Easy.
Hey, it's Kaylee Cuoco for Priceline. Ready to go to your happy place for a happy price? Well, why didn't you say so? Just download the Priceline app right now and save up to 60% on hotels. So whether it's Cousin Kevin's Kazoo Concert in Kansas City, go Kevin, or Becky's Bachelorette Bash in Bermuda, you never have to miss a trip ever again. So download the Priceline app today. Your savings are waiting.
Go to your happy place for a happy price. Go to your happy price, Priceline.
Do you know the 3 most important rules in brewing? Sanitation, sanitation, and sanitation. And no one does it better than 5-Star Chemicals. 5-Star knows sanitation. You can only sanitize clean equipment. And 5-Star knows how to clean, too. For craft brewers and home brewers, 5-Star has what you need to keep your fermenters, serving tanks, kegs, and draft lines sparkling and free of any beer-spoiling bacteria. PBW, caustic, acid cleaners, Star San, SaniClean, lubricants and defoamers, pH stabilizers, and more. 5-Star Chemicals has cleaning supplies, safety supplies, heat exchangers, pumps, hoses, and valves. And 5-Star is proud to offer eco-friendly products that exceed customer expectations. If you have a cleaning problem, you need the 5-Star solution. Visit 5starchemicals.com or call 800-782-7019. 800-782-7019 and get the 5-Star treatment today. Are you looking for a simple brewing system that's great for all grain brewing, but everything on the market seems to be full of compromises? Blickman Engineering has the answer. The Blickman Brew Easy All Grain Brewing System. The Brew Easy is a complete system with easy upgrades and a beautiful compact design, perfect for any size brewing location. At its core, the Brew Easy is built on 2 gorgeous Blickman Boilermaker brew kettles, a high-temperature March pump, and either a top-tier gas burner or the new Boil Coil electric heater. The Brew Easy adapter lid allows the pots to stack on top of each other, forming an efficient, strong, and compact brewing setup that comes in 5, 10, and 20-gallon batch sizes. Upgrade your Brew Easy system with full automated control by adding a Blickman Tower of Power temp controller, and make moving around easy with the Blickman Kettle Cart. The Brew Easy is modular. If you already own a Boilermaker kettle, you can build your Brew Easy by purchasing just the modules you need. The new Brew Easy all-grain brewing system. See it today at BlickmanEngineering.com and brew with Blickman quality on your new Brew Easy.
Back to the 2 guys that know how to turn beer into beer. This is Brew Strong.
Longtime BN homie Michael Fairbrother. He wants you guys to check out MoonlightMeadery.com. Moonlight Meadery, mead for any occasion. Moonlight Meads are the reference standards for mead categories in the BJCP style guidelines. So if you want to learn about meads, get yourself some Moonlight Meadery meads and read along in the style guides as you sip and enjoy them.
And then be prepared to forget everything you learned once you're done with the bottles.
Right. Yeah. Once you finish the bottle, you'll have to start over again. So, and right now you can save 10% on 2 or more bottles by using BN Army at www.moonlightmeadery.com/shop. Wonderful, delicious, category-defining Moonlight Mead. Check them out and let them know we sent you. Use the offer code BNARMY at checkout, moonlightmeadery.com/shop. All right, we were talking about measurements and devices and things like that, but I want to backtrack just a little bit and kind of put some context around all this. John Palmer, can you tell us why measuring temperature accurately is important?
Well, so many of your measurements depend on temperature as part of the basis for that measurement, whether you're talking about liquid volume, gas volume, rates, flow rates. Volume is usually dependent upon temperature and pressure.
Mm-hmm.
So
volume of liquid,
that's
volume
why,
of gas.
Yeah. So, accurately knowing your temperature, calibrated and so on, is very important to getting volume measurements correct. Mm-hmm. From there, getting your efficiency, your specific gravity, all these things depend on temperature.
Fermentation?
Yeah. fermentation.
I can't tell you the number of times people are like, yeah, I fermented it, 67, and, it's coming out all. I'm like, well, are you sure? And they're like, oh, yeah, I just found out it was actually closer to 80.
Yeah.
Like, okay, well, there you go. Might have affected your beer in the end. Let me just throw that out there. Okay, so yeah, it affects just about every part of the brewing process. Temperature is so critical. From your mash to your sparge to your fermentation to everything.
Yeah.
Okay, so Monsieur Blickman, can you run us through what are some of the devices we can use to measure temperature?
Well, one of the old school devices are the glass thermometers. Those have been around for a long time. They make lab grade ones that are quite accurate, and that over certain ranges. I believe the most accurate ones are mercury filled, but it's probably not the best device to use in a brewing application, since it's somewhat poisonous.
No, only if you drop it and it gets everywhere.
That's right. That's right. So, those are, if you can find one of those, those can be a great reference thermometer. A lot of those will, and they really don't, that I've ever heard of, go out of calibration. So that can be a good reference thermometer, just so you can check your other thermometers that you're using. That's probably one of the first ones. There's probably one of the most common are a bimetallic thermometer, and they're quite durable. They use two different types of metal that expand at different rates, and that's so if you opened up a thermometer, you'd see a little wire that goes from the needle down to the tip of your probe, and there'll be a little coil of metal down there that is made up of two different types of metal that expand at different rates, and then that is calibrated so that when it expands, that makes or gets hot, that makes the one expand faster than the other, and it turns the dial. They're pretty old school as well. They're generally plus or minus 2% of the scale, as I recall, on those.
And very common in homebrew. This is the kind of
they're very common. Yes.
Thermometer that you generally find on kettles and things like that, because they're fairly inexpensive, fairly accurate. They can be recalibrated, usually with a screw or a nut.
Right, on the back, and those if they've been bounced around or in transit and things like that, they can they can move just a little bit, and they will need calibration. So when you buy one of those, make sure that it does have one that has an adjusting screw on the back, unless it's something you just want ballpark temperatures on, which I wouldn't prefer. So those are ones that I would definitely frequently check those.
Even throughout use. It can become out of calibration, not as much as if you're like whacking it around, but just through essentially wear and tear.
Wear and tear.
Perhaps a little bit of liquid leaks in or humidity gets in there that can affect it. And that said, you do want to protect those from the heat of your burner, because you can break that hermetic seal and they can get fogged up inside and start getting corrosion, and so do protect those. That's for sure. And you'd calibrate this with the crushed ice and stirring it with some water or boiling liquid, or again, like you said, depending on the use, if you're using it more for fermentation, maybe you want to calibrate it with the crushed ice as your more important point. Because if you do both the freezing point and the boiling point, sometimes these things won't calibrate both ways very, very well. So you kind of have to lean towards one or the other. You go back and forth a couple of times, and Either you can kind of cut your error between both, or you can lean towards the boiling. If you're looking more for a mash thermometer, you can lean towards freezing if you're looking more towards low temperatures.
Right, absolutely. And it's important to recognize you can't just take it for fact that is the exact number. People say, I can hold my mash within 1/10 of a degree. Well, that's what the meter says. That doesn't necessarily mean that's where it's at. But other types of thermometers, we're starting to see people use like infrared thermometers. And the thing I will caution you with infrared thermometers is the emissivity of the surface. In other words, the color, the shininess,
reflectiveness.
The reflectiveness can change that number drastically. So those I've used those in troubleshooting stuff for engines and all sorts of different things in my past, and they're great for troubleshooting things, but I don't use those for consistent measurements. Delta T's, temperatures on the same surface, maybe.
Right.
But
and I would throw in there that there's a few things to kind of fix that. Sometimes you could take a thin piece of electrical tape or
black tape,
or painter's tape, put it on the surface, let it equilibrate, and then you can use that if it's a shiny stainless surface or something like that. The other thing I see people doing frequently is they put the infrared thermometer really close to the surface. And really, you need to back away. The problem is there's a ratio of distance to the measurement spot. So different infrared guns have different ratios. Some of them,
different sweet spots.
Yeah, you get closer, and it's so you're measuring. If you get close, you're measuring this tiny little dot, and it's not enough real information to get an accurate reading. You need to back up, and you need to measure, a 1 inch or a 2 inch surface, so that you're getting the true reading. And that's going to vary based on the type of gun. But even the cheapest ones do a pretty good job. And when you're trying to just determine, like you said, troubleshooting, we use it frequently on just a sanity check on certain things. It's like, well, this gauge is reading this. Okay, let's just double check. Yeah, sure.
Yeah.
They're both reading. Or steam traps at the brewery. The way you can tell if a steam trap is working or not is you measure the outflow side, and if it's boiling, well, no, it's not stopping the steam, so it should be lower, and the input side should be higher. So that's one you can and those tend to be painted black, so it's really easy to check with something like that versus trying to guess as to whether your steam trap has gone bad or not. So
the flat black surfaces are definitely the way to go if you can do that. They also have meters that will you can enter an emissivity number, and that helps. But in my experience, those are great for troubleshooting devices. They're fast and convenient. You don't have to, get a probe into the liquid or any of that other stuff. It's just a pretty quick way to go.
Well, and I recommend them for, the commercial brewery. You can check if, cold air is coming out of your, HVAC ducts, or warm air. It's common for HVAC people to use them. A lot of good uses around the brewery, and again, they're fairly cheap.
Yep. And then moving on to some of the other that a lot of people use or heard about is thermocouples. And a thermocouple is two dissimilar metal wires that are welded together at the tip. And one of the real common ones is iron constantan, and they create a very small voltage, and you can measure that voltage. And they've got some advantages. one of the things I like about them is they're extremely inexpensive. They're super tough and durable, vibration resistant. They can handle some of them over 2,500 degrees. So, I mean, they've just got wide temperature ranges. They're also fast. The drawback with them is they're a little less accurate than others. 2 to 4 degrees, plus or minus 2 to 4 degrees Fahrenheit is somewhat typical. They also, over time, will tend to drift. And drifting is the temperature reading that, the bullseye point kind of starts shifting a little bit as they, perhaps corrode a little bit or, just get old. They're lead wire sensitive. You have to use the right lead wires for it to work properly. And if you're in an electrical noisy area, they can be a little sensitive to that and give you some erroneous readings. But thermocouples, they're a well-known, been used forever and ever device that I have used those for years in tons of different applications. But one of the next ones that a lot of people hear about.
Hold on. Let's not just blow through. Let's talk about thermocouples a little bit more. Now, this is common. You'll see them on, when you buy a Johnson controller or Ranco controller, whatever, which are really common in home brewing. Often they come with a thermocouple on them, right?
A lot do, yeah. More the older ones. Some of them are also thermistors, which we can talk about in a little bit too.
Mm-hmm. And the wiring on it tends to be a 2-wire. There's no such thing as like a 3-wire or 4-wire thermocouple. It's always just 2, correct?
I think they have some that you try to use in lab grade things that have like junction compensation.
Mm-hmm. A reference
but
line.
I've never used those at those kind of temperatures. We used to use them at Caterpillar for exhaust temperature measurements, and they were always accurate enough at the temperatures we needed. But generally, what you'll see is just a 2-wire.
Mm-hmm. Well, and what's happening is they're applying voltage through this, or the voltage is occurring because the 2 dissimilar metals are being heated or cooled. And
right, it's the dissimilar
voltage.
metals create a voltage,
a very tiny voltage. So, if your wiring is not has a lot of resistance to it, and your thermocouple is a long ways away, that could be an issue.
Dirty connections,
right.
Loose connections.
How long a wire can you use on a thermocouple? That also must impact it.
It does, and it's because of that, the voltage and the resistance of the wiring. Generally, I try to stay, 50 feet or less. Mm-hmm. There's some, and in most, like in home brewing, that's plenty. I mean, that generally doesn't need to be corrected for.
John, does the measurement change if you change the length of that lead?
Generally not until you get to really large distances, and then you can start doing some corrections. I'm going to see if there's a look up here for some junction compensation for thermocouples.
But I think it depends on both the type of wire used as your leads to your thermocouple. Right, the amount of resistance.
Mm-hmm.
You use cheap wire. When you get a low resistance wire, it's quite a bit more expensive than just some general wire. Now, if your lengths are short, if you're talking just a few feet, that amount of resistance doesn't tend to be an issue. But with length comes great responsibility. Comes more resistance, and that can impact your reading. So a lot of these thermocouple reading devices, the actual meter itself, will have compensation, an offset, which is essentially your calibration.
Yeah. Mm-hmm.
And because of that change
and here I'm finding a
resistivity.
guideline under 100 feet with 20 gauge wire or thicker is generally not going to be a problem unless you're in a, again, as I mentioned earlier, an electromagnetic interference area where there's a lot of electrical noise.
Mm-hmm. So if you're a brewer and you have a thermocouple that has a long lead, say 20 feet, and you cut that down to 10, there's going to be no change really in the measurement due to that change in length.
Not enough to worry about. And if you're really trying to get it super precise, you can calibrate after, at a known temperature. Yeah. You can calibrate for that.
Yeah.
In fact, we've got a thermocouple calibrator. It actually gives a thermocouple signal, and you can run that through the meter and measure it, if you really want to dial it in.
Yeah. Well, and that's more critical than when you're over 100 feet in length on these leads, as
Absolutely.
You would be in a brewery situation.
Well,
particularly a home brewery.
Probably even more important in the commercial brewery and in home brew as well is one of the things that I see happening is when any wires in a brewery are not properly connected. If you're making any sort of connections, any junctions, any sort of terminations on a wire, you need to use grease filled. You need to use things that will occlude moisture and all that, because you're working with caustics. Even though caustic may not actually hit that connection, when you're working with hot caustic, things like that, the vapor does get in the area and will corrode those connections. You tend to see a lot of corrosion on those fine wires, and it can be a real problem. That's more of an issue than the length of the wire.
Yeah, and you definitely want to have those liquid tight. I mean, you'll see a lot of these like lab type connectors. You just plug it in the back. Those things are going to corrode fairly quickly. Mm-hmm. In a harsh environment, you definitely want things very well hermetically sealed, so you're not going to get humidity in and out.
Right. And if you have any removable contacts, you're going to want to get yourself some contact cleaner and use it on a regular basis, just to ensure that those contacts are clean and good. I've seen it where fermenter temperature all of a sudden is off by 50 degrees, and it's like, well, what happened? It's like, well, the corrosion, and eventually there's some very slight vibration, and bing, all of a sudden it's not reading correctly. So you need to do regular maintenance, especially of removable contacts. Get yourself a contact cleaner. You can get it off of places like Amazon. I don't think your local homebrew shop has it, but it'd be a good idea if they did stock it and recommend to people building their systems and stuff to use something like that. Let's take a short break, and when we come back, we'll talk about RTDs and thermistors and a lot of other stuff, all about measuring temperature right after this.
Are you a member of the White Labs Customer Club? If not, you should be. It's the easiest way to earn free stuff for turning in your old homebrew labels from either Vials or Pure Pitch. All you have to do is save your labels and redeem them for things like free yeast, an exclusive White Labs t-shirt or sweatshirt, and even the opportunity to brew with the yeast man himself, Chris White. Signing up is easy. Just go to whitelabs.com/customer club, fill out the registration form, and then mail in your labels. They will return the favor by sending you awesome White Labs swag. Go sign up today at whitelabs.com/customer club. White Labs, pure yeast and fermentation since 1995.
Back to the beer guys that make other beer guys look like wine guys. Brew strong.
All right, I wanted to tell you about Grog Tag, your one-stop homebrew customization shop. They have it all, from reusable beer and wine labels to durable metal signs, high-quality coasters, and everything is customizable. So get creative over on grogtag.com with one of our hundreds of templates, and we'll print it on high-quality materials and ship it out to you. It's easy. Check out grogtag.com today and use the code BNARMY to save 10% on your next order. That's grogtag.com. All right, we were talking, we were deep into thermocouples, and I think we pretty much covered. Did you guys have any other thoughts about
I do.
Oh, there you go. All right.
One thing to remember with thermocouples is there's I don't know, 10 or more different types of thermocouples that are different types of wires that are for all sorts of different uses, high temperature, low temperature, blah, blah, blah. The most common ones that you will see is a J type and a K type. And both work fine for brewing temperature ranges. But the important thing is to know which kind you have and that you set your meter to that type, because they will read, they just won't read correctly. So you can plug a K type into a J type PID and it'll read a number, but it won't be right. You have to get that set right. So just make sure you know which type you have and get your meter set accordingly.
Now, knowing our listeners, I just got to say, they're going to want to know what does J and K stand for?
J and K are both letters of the alphabet, and that's about as far as I know. I've never really been fascinated enough and curious enough to look that up and find out.
Well, and I wonder if this is the story, because I used to teach scuba diving, and one of the things in scuba diving, there used to be a J valve and a K valve, and one had a like a emergency reserve type of setting. When it stopped delivering air, you pulled down on this lever, and it delivered like your last 100 psi that was in the tank. The problem was sometimes it was down, you forgot to set it up, so it really kind of went out of favor. But there was J valve and K valve, and I used to teach students. I'm like, yeah, it kind of looks like a J, kind of looks like a K. They're like, oh yeah, I see it. But that's not what they were named. They were named that way because in the very first scuba gear catalogs, the one type of valve was item J, and the other type of valve was item K. And so people just started referring to them as the J valve or the K valve in the catalog. And so the name stuck, and it just became that. So I'm just wondering if thermocouples would be the same thing. It was like they had like a whole list of them, and it was A, B, C, D, E, F, G, and then this was J and K became the most popular ones, and so people just kept referring to them that way.
I believe that's probably the case.
Now I'm going to have to look that up.
Right. But
the old Omega book or something.
Right,
yeah.
Exactly. Whoever first came out with them, they had a list of them, and probably J and K. There you go. I'm just here to confuse things.
Well, do you remember how we used to covet catalogs like that before the internet?
Oh yeah,
right.
To get the Omega catalogs was awesome.
Yeah.
Or the McMaster car catalog.
Oh yeah,
big fan of the Sears catalog. The women's section, the lingerie section. I mean, before the internet, I'm just saying.
Yeah.
So predictable.
Okay. Now that we got
and the
that
Williams catalog too.
Yes. Catalogs. All right, we had talked about thermocouples. All right, so that wraps up thermocouples. What about RTDs? That's a very common device as well these days, right, John?
Sounds very techy, yeah.
Yes, stands for Resistance Temperature Detector. Or there's probably a number of different ways you can have that. But basically what that is, the most common one is a 100-ohm platinum RTD. They change resistance with temperature, and the 100 ohm simply means at 0 C, the resistance of that is 100 ohms. So what is really nice about that is you basically just have a voltmeter is essentially what your gauge is that's reading that resistance. So it puts a known voltage across it, and current through it, and then it can measure the resistance. So that's essentially what you're doing there, and they're extremely linear. That's one of the nice things. So if you were to plot temperature versus resistance, it's nice and linear and consistent. That's one of their hallmarks. They're kind of the go-to sensor for very high precision. They tend to be extremely repeatable. there's a couple different, there's like B type and A type, or class B or class A. And that just basically means how much more precise is it? And of course, a class A RTD is more expensive than a class B RTD. They have a reasonable temperature range, from, I don't know, like probably minus 200 Celsius up to 600 Celsius or so. There's probably some that go further ranges, but certainly much more than you would really need in a homebrewing environment. Even a commercial brewing environment, unless you're trying to measure exhaust temperatures of a burner or something. But they're unfortunately the most expensive of the devices. The other drawback is that they don't have a large resistance change over their complete range. For example, between 0 and 100 C, you only have about 30 ohms that it changes. So you have to have a very accurate voltmeter connected to it, essentially. So that's one of the things to factor in. They are, like we're talking about with the thermocouples, not really being that sensitive to lead length. RTDs definitely are. They do make some 2-wire RTDs, because you really only need 2 wires to measure resistance. But I rarely see them in use. You almost always see a 3-wire.
Well, the third wire is that so you can go longer lead lengths. So I think you can go 500 or 1,000 feet, and with the 3-wire, because what they do is send the voltage down both wires, and then they measure also the difference in voltage that has gone through because of the resistance of the wire. The voltage changes when it reaches there, and so that's part of what they take into calculation to see what the effect of the leads was, and that gives you a more precise resistance reading, right?
Absolutely. You're measuring, what they're doing is they're measuring the resistance of the wire, which may be several ohms, and that will affect the reading the longer you get on lead. So what they do is they just use the same type of wire for all of it, and then they measure the one of the leads just to see what the resistance of just the wire is, and then they compensate for that internally, and that's how you go about doing that. So those are the most common is the 3-wire. Usually you'll have like 2 reds and a white. So you'll generally have 2 that are the same color, and one that is your signal wire, if you will. That'll be a different color, like black or white. Again, most PIDs and everything else, they all use a 3-wire. There are 4-wire RTDs that has like a junction compensation in it. I've personally never use those, probably in super high precision or high noise areas or something. But you'll just see the 3 wires most commonly, and the 100 ohm is real common. Now there are 2 different types. There's the U.S. curve and the European curve. It's like a 385 versus 392. I may be slightly off on those numbers. Is
one
what
curves
the coefficient
to the left,
is.
one curves to the right.
Yeah, it must be left or right.
Yes.
Again, it's just important to know which one you have. And most PIDs and meters I've seen, you can set it for which curve you have. In the States, obviously, most of them are going to be the U.S. curve. So, some, other cons to that is they're a little, and sometimes it's not bad. Is they respond, they're one of the slower responding ones, somewhere between 1 and 50 seconds. So sometimes if you don't, if you're having temperatures that are just kind of swinging up and down real quick, this kind of will average it for you if you have a slower responding one. So it's not always bad.
Right. No rapid fluctuations.
Right. Particularly if you're trying to use that as a controller, you don't want the controller thinking it's bouncing all over the place. So that's sometimes good, sometimes not good. You really kind of just need to look at take a sensor and figure out which the best one for my application. They don't like vibration particularly well. That's why on engines we'd always use thermocouples, just because they tolerated that a little better. And you do again need a pretty accurate meter to discern the differences in those resistances. But they're nice and stable and perfectly suitable for the temperature ranges we use in brewing.
Okay. One little tip for people on RTDs, especially commercial brewery owners that are doing longer runs. You can find RTD wire, but a lot of times they're just labeling something that is low resistance wire, and you can find similar low resistance wire sold as not RTD wire, and it's really the resistance that means everything.
Good copper wire, you're good.
And you do want to make sure they're all the same gauge wire.
Right, and you can get like a 3-conductor, low resistance, and good copper. It's the amount of impurities in the copper, the amount of oxygen in the copper, things like that affect the resistance. And I've been buying off of Ram Corp, I think it is, and they tend to have a really huge selection of wires by the spool at reasonable prices. Not advertisers, but you might check them out if you're looking to get 1,000 feet of wire for your RTDs, like I have in the past. So another thing you'll see with RTDs, particularly in industrial environments, so you're not picking up noise or other things as well, is they'll use an RTD that on the junction box end of it will have a signal converter that will actually convert that to a 4 to 20 milliamp signal is a pretty common one. And then you're just basically sending a current to the meter that's just measuring that current and then converting that to temperature. And so that kind of gets rid of the lead length issue as well. So that's another way I've seen it done. Right. Okay. And then what about, you mentioned this earlier, thermistors?
Yes, thermistors there's just been a lot of work on those the past, 10, 20 years, and you're seeing a lot more of those. A lot of people don't even realize that they have thermistors. In a lot of the like Ranco and other devices, Inkbird and whatnot, they're actually starting to use thermistors. They are a ceramic or polymer material that changes resistance with temperature. They have, the RTD was at 0 C was 100 ohms. A thermistor, they can vary where they want the sweet spot, which is kind of nice. But they will be at their reference temperature will be 10,000 ohms, which is great, except that it's extremely nonlinear. So there are equations that you have to have in your reading device, or not the equation actually, but they will program it to convert that nonlinear resistance into a temperature. So they're about as inexpensive as thermocouples. This is the interesting and convenient thing for brewing. They are actually can be even more accurate than a Class A RTD over the range that you do brewing. So in that, 0 to boil, 0 C to boiling 100 C, they're actually quite accurate and very precise. They're super fast responding. Vibration tolerant. Again, that's not really that. I've never been around a brew house that was vibrating that much, but the main con is that smaller temperature range. So they have limited applications for like higher temp things. I think they go up to typically, just a few hundred Fahrenheit in that range typically, and down to minus 20 or so, I think. But they're really quite well suited for that. But the real nice thing is with that high gain or that big resistance change, just from a 0 to 100 C, they'll change 20,000 ohms. So they really, and that's where you don't have to worry about lead length compensation, because the resistance of that wire might, over 1,000 feet might be, a few ohms, and it's like, well, big deal. I'm measuring in thousands of ohms here. Mm-hmm. So that's pretty nice. Even if you have a bad, somewhat slightly bad connection, mm-hmm. That contact resistance may not be enough to noticeably change that reading. So they're an interesting device. They're nice and stable, very inexpensive, and I certainly wouldn't shy away from using those in the environment for brewing. The only drawback is some PIDs don't have the capability to read them, and they do change from manufacturer to manufacturer, because like I was saying, they can just change the mix. And then you can kind of shift the sweet spot of the accuracy of that device. So
interesting. Okay, yeah. So matching your meter to your probe means a lot. Let's take a short break, and when we come back, we'll wrap up all about temperatures and measurements right after this.
Brewing great beer is a process of continuous learning, and the best books on every aspect of brewing can be found at Brewers Publications, with more than 50 awesome titles like Modern Homebrew Recipes by Gordon Strong, Designing Great Beers, the Ultimate Guide to Brewing Classic Beer Styles by Ray Daniels, American Sour Beers, Innovative Techniques for Mixed Fermentations by Michael Tonsmeyer, For the Love of Hops, The Practical Guide to Aroma, Bitterness, and the Culture of Hops by Stan Hieronymus, and Radical Brewing, Recipes, Tales, and World-Altering Meditations in a Glass by Randy Mosher, plus many, many more. These are the books and the authors with the knowledge to push your brewing farther than you thought possible. And you'll find them all at fine homebrew and book retailers everywhere. And visit the website at brewerspublications.com. Brewers Publications, all the best on beer and brewing.
Like the Lance Armstrong of the beer world. Except for that nut thing. This is Brew Strong.
I wonder if people remember Lance Armstrong's nuts and his nut thing. I think people may be forgetting by now.
It's great that you still find it amusing after all this time.
It's so amusing. It cracks me up. I remember that. I remember that day writing that copy. And I'll tell you what. Our good friends at the American Homebrewers Association, I doubt that they remember that, but they are makers of the free Brew Guru mobile app. If you love brewing and beer and saving money on beer, you need Brew Guru in your corner. This app offers a searchable database of homebrew recipes, including popular craft beer clones and hundreds of award-winning recipes. What's more, Brew Guru has a searchable map of deals at breweries, beer bars, and homebrew shops. Grab the free Brew Guru app for iPhone and Android devices and follow the path to good beer. All right. So talking about all these different types of devices to measure, one of the things that always comes up, and I've always said, just tape your sensor to the outside of your fermenter, maybe cover it with a piece of foam insulation or something, and you're good to go. do we need thermal wells for this sort of thing?
That is a very good question, and I get asked that pretty frequently with our fermenters. What I'm very much a simple is better kind of guy. So in my
I prefer less penetrations myself.
What's that?
I prefer fewer penetrations myself.
Definitely. So I actually use the aluminum duct tape. The metallic aluminum foil duct tape because it conducts, and I actually use that to tape it onto the side of my fermenter.
They sell it in the HVAC section. It's in your local hardware store.
Right. Yeah, and a roll of it will last you an eternity. And so I've used that and measured using the same device inside, so there's no difference in the measuring device. So I'm just looking for the delta T on a 14-gallon fermenter, the difference between taped on the side with the aluminum foil tape that is thermally conductive. So you're really getting that temperature right to that sensor, and then dropped it after sanitizing, of course, into the middle of the fermenter, and it was less than half a degree Fahrenheit difference. So not enough that I felt like I needed to use a thermal well. Now that said, the one nice thing about thermal wells and where they really came into use was where if the environment inside the vessel was under pressure or under high pressure or very corrosive and might be harmful to the sensor, or if it was mission critical and you needed to be able to change that sensor out without draining the vessel, those were definitely where thermal wells came into play.
Well, we use
the other thing is a very large vessel. Large vessel. You really need. Then you're going to get a little bit more temperature stratification through it, not only vertically but radially. From the center towards the edges. So for commercial application, thermal wells are really a necessary thing.
Well, we use them on our large fermenters. Really because the fermenters are insulated for one.
Yeah.
So you can't just put a sensor on the outside. But even then, if we're questioning one of our meters, we'll take a handheld fluke meter with an RTD tip and touch it to the door of the fermenter just to, compare temperatures. And I assure everyone that temperature is exactly the same as the temperature inside in the middle of the thing. It's going to be pretty darn close.
Yeah, it really is, and it's kind of one of these. It's not elegant or cool, but it works. Now, what you don't want to do is just like if you're using a freezer, upright freezer, or chest freezer or refrigerator, you generally don't want to just dangle the probe in the air. Because it can, especially for something that's generating heat, because it can cause your refrigerator to cycle more often than it needs to.
Well, and you want to measure the fermentation temperature of the beer, not the air around it. The actual beer is what you're controlling the temperature of. That's fermentation control. And there's just room control or freezer box control. And,
like a cellar control. If it's like kegs in a
cellar,
geyser,
sure.
There's no heat being generated, so you're fine just placing that in the air.
But when you're fermenting, you need to control the fermentation. Not people drive.
Absolutely.
Oh, I'm so passionate about that. Well, and what about something like thermal paste? When we have thermal wells, and I used to fill them with thermal paste, and then I stopped after a certain point. I'm like, the conductivity, the stainless thermal well, it'll get there eventually. I mean, I don't care if it takes 5 minutes, 10 minutes. It doesn't matter to me.
I use thermal paste in applications where temperatures move quickly, and you want to be able to measure them because you need something to transfer that heat
rapid
to that
fluctuations,
sensor. Or, and I'm sure Jamila's had this problem frequently if your thermal well is too shallow.
Paste on my probe?
Yeah, and you can't get your probe's not in there
right all the way.
You can get some environmental effects where the outside of the device will influence the temperature inside. Mm-hmm. So if you use the paste, then you get more of that conductivity inside. But in general, I find it's not enough of a difference in temperature to worry about.
Right.
I mean, you're talking tenths of a degree, and it's different if you had like a 1-inch thermal well and you're putting a tiny little probe in there versus something that's fairly close fitting.
Okay, enough of the personal stuff.
I knew you were going to run with that.
All right, so let's wrap up with some final recommendations. I mean, it sounds like there's a use for pretty much every one of these devices that we talked about for measuring. I mean, the spirit thermometer, the bimetallic, that's very common and great to use. The infrared could even be used. Thermocouples, RTDs, and thermosistors.
Yep.
So any general recommendations? I think maybe the biggest recommendation is having some way to calibrate your measurement devices. Use them often. Check your temperature, your mash, your fermentation,
Yeah, yes. I think that is the most important point, Jamil. Yeah.
And the thermopens, I found them to be a reasonably a viable home calibration device. They actually use a thermistor with a very accurate sensing algorithm inside, and I found them to be pretty solid as far as being able to use that for calibration. And it's pretty easy, and you'll just want to have a reference temperature and put both probes that you're curious about together, and you can check to see if you're on. And then the other thing too, I try to tell people that are worried about 1 degree difference in their mash temperature, is I always tell them the good Lord did not calibrate enzymes to tenths of a degree.
Yeah, doesn't matter.
Yeah, the big thing is that you can be consistent. Mm-hmm. Not that it has to be, exactly this, or it's going to be crappy beer. Mm-hmm. It just doesn't, as you know, Jamel, it's important, but it's not, just ridiculously important. And some of the other things are, when you're measuring things, you just want to make sure that if something doesn't seem right, question your measurement device. And then when you're selecting a measurement device, just get one that's going to be accurate enough for what it is you need to do.
There you go. Good advice from the man himself. Great show. If you're listening live, stay tuned. We've got another one coming up. We're going to do more measurements. We're going to talk volumes. Are we going to talk volumes?
Yep.
We're going to talk volumes next. And again, if you're struggling with your brew process, getting volume measurements down can really help. So stay tuned for that. And check out all our fine sponsors. I highly suggest you go to blickmanengineering.com and check out all the goodies that they have there. They're always inventing new things to improve your brew day. So check that out. And while you're there, maybe send an email to our fine sponsor, John Blickman. You can send it to feedback at Blickman Engineering. Tell him how much you appreciate that he pays for the show so you don't have to. And you can check out the Brewing Network store, thebrewingnetwork.com/store. You go there, find lots of goodies. You find hoodies and hats and shirts and all sorts of other good stuff to enhance your street cred around the brewers and the breweries and things like that. I tell you, when you go into breweries and they see you wearing some BN gear, they know that you're a passionate person about brewing and beer, so it can pay off in weird ways. All right. Thanks, everybody, for joining us. Until later, brew strong.
Brew strong, everyone.